All right, this video is going to be, it says simplifying rationalizing. The notes have a lot of different radical stuff going on. This video is just going to be on simplifying radicals. First thing, we'll talk about the parts of a radical. First thing you have is what we know is the square root symbol, but we need to start recognizing it as the radical sign. And then over here underneath that radical sign, we're going to have the radicand. And then the little number right here, which in my class you're not going to see anything. If there's nothing there, that means it's a square root. But if you add an additional, you can have the cubed root. And after 2, once you get to the cubed root, you have to start putting a number. This is called the index. We will never talk about the index in this class, but we will talk about the radical sign and the radicand. Next, we have these perfect squares going from 1 squared to taking the square root. We need to memorize as many as possible. This is going to make things a lot easier when dealing with our radicals and everything else in this chapter. So the more of these you have memorized, frontwards and backwards, the better off you're going to be. Now, with your simplifying radicals, there are a couple different ways that you can do this. One way is going to be factoring. And there's also 2 different ways we can look at factoring. Factoring is going to be using your prime numbers. The first one, let's go ahead and take the square root of 63. What we want to do is we want to take a look at our prime number starting with the lowest. Your prime numbers, make sure that we have these written down. Now these are just some right here, 2, 3, 5, 7, 11, 13, 17. Usually when you get out to 13, 17, that's probably about the highest we go with the prime numbers with our factoring. So what we want to do is whenever we take this 63 to do the prime factoring, I always tell my students start with the lowest prime and move up from there. So what that means is 63, the lowest prime 2. Can I divide it by 2? No. So move up to the very next one. There's a reason to do this. When we move up, can 3 go into it? Yes. So factoring this out, this would be 3 times 21, and this leaves a prime, so I don't have to worry about factoring both sides out. So now we go to the 21. Again, 2 cannot go into it. 3 can. So we have 3 times 7. And we look at 7, and that is a prime number, so we are done factoring. Now we need to look at our partners. So what I call this, whenever I teach this is the radical house. You have the outside out here, and you have the inside underneath the radical roof. What's going to happen is you're going to find your partners. Outside the radical house, there's a 3-legged race. In order for there to be a 3-legged race, you need 2 people. So in this case, you're going to need 2 of the same numbers. And the reason with the 2 of the same numbers, you can't partner 3 and 7. Think about it, a 3-legged race with a 3-foot person and a 7-foot person. It might be funny to watch, but it's not going to work. So we want to find numbers that are alike. So here we have 3. Now, on the outside of the race, there's only 1 3. Please be careful with this, okay? The reason is because when you have the 3-legged race, if you and your partner cross the finish line first, you're not getting first and second place. You're 1 contestant getting 1 place. So once we loop these together and tie you together, you are 1 person. Any leftovers that do not have a partner, stay inside and do their geometry homework, okay? So here, I didn't mean to do this. If you use colors, make sure you put that in the color so we can see it, okay? So that's my story about the radical house and how my best way to help you with what goes inside and outside. Next, we'll look at the square root of 72. I'm going to show you another way. When you start factoring, you're going to get a lot of stuff everywhere, and it might be hard to find your partners. So what I do is what I call the division tower. It's still using prime numbers. This is what I generally will almost always use except for whenever I'm teaching this. The division tower, instead of starting at the top, we're going to start at the bottom down here. So we're going to start with the 72. Okay, we're not putting the radical sign over it. We'll just do 72. We're going to do the division symbol. We're going to now divide, basically what we're doing over here, starting with the lowest prime number. Can 2 go into 72? Yes, it can. So we'll divide. 72 is divisible by 2. We get 36. Keep starting with the lowest number. Okay, new number divided by. Can 36 be divided by the lowest 2? Yes. And we're going to get 18. Keep dividing until you have a prime number at the top. So here, 18, we can divide it by the lowest prime number 2. We're going to get 9. Keep going, it's not prime yet. 9, now 9 cannot be divided by 2, so we're going to move up. Can it be divided by 3? Yes, and we're going to get 3. Some people will go ahead and divide until they have 1 at the top, okay? But here, I just go ahead and stop here, and with this, we'll go ahead, same thing with that division, the radical house. We want to find all partners. Here we have a pair of 2s. They're going to join together to create 1, 2 outside. And then here, that 2 does not have a buddy. So he's going to go inside the house. We move up here, and we've got another pair of 3s. We've got a pair of 3s, which will join together to become a single 3 contestant. The rule is multiply everything on the inside together, multiply everything on the outside. So we will multiply these, and you will get 6 square root of 2 as your final answer. It will work with the factoring as well. The next one, we're looking at what happens if we already have a 2 outside, okay? In this case, what this means is we're already going to have a contestant waiting outside for any other partners. They're at the starting line waiting. So we need to take now the radicand, and we need to go ahead and either do your factoring, whichever way, whether you want to do factor down, like the tree roots over here, or if you want to do the division tower, whichever method you prefer. Here, if I do the division tower, I'm going to divide by the smallest prime number possible of 2. I'm going to get 4. I'm going to keep dividing by the smallest prime number possible until I have a prime number up top. Now I'm going to go join my pairs. And I always start at the bottom and start circling upward. Doesn't matter. Just don't jump around. So here I have a pair of 2s, so it's going to go outside the starting line. And then this little lonely 2 doesn't have a buddy to partner up with, so he's going to stay inside. Remembering that, multiply everything on the outside together and everything on the inside. So this will be 4 square root of 2. Okay, this next part, I'm going to show you how you can do this, going with a perfect square, doing the exact same problems, okay? Here with the square root of 63, and this is going to be a factoring downward. With your square root of 63, you need to look up here and figure out what perfect square can go evenly into 63. So if you decide to do it this way, you need to know your perfect square. You need to have your perfect squares memorized. And what we will find out is that we have 9. 9 can go in here 7 times. So 7 is one of the prime numbers, so we're done with 7. 9 can then factor out to a 3 and 3. What this does is help you get your doubles together also. So again, we'll take this. The partnership is going to go outside the radical house, and the single by itself will stay inside the house. Okay? And the same thing works with everything else. If you'd like to see that, check with your teacher. I'm going to go ahead and skip that part, since that's not really the method that I do. Now, next, we're going to go ahead and take a look at 3 more problems on this. Again, I am going to do this using the division tower. Okay, what I'm noticing in all 3 of these is I already have a guy sitting at, a person sitting at the starting line at the 3-legged race. So I'm going to go ahead and I'm going to put my little radical sign over here, and I'm going to place this guy at that starting line. And I'm going to be careful not to draw that arrow too far in, because I don't know how many numbers we're going to be multiplying. So now I'm going to take that 32, and I'm going to do the division tower. I'm going to divide it, again, starting with your prime numbers. We want to start with the lowest possible. And here are some of them. The lowest one possible will be 2. When I divide by 2, I'm going to get 16. Keep dividing by the lowest. 2, divide by 2, we get 8. Divide by 2, we get 4. Divide by 2, we get 2. And then we're left with that prime number at top, so we're done. Let's go ahead and find our partners. Here's a partner, so we have another 2 that's going to come join us at the starting line. Here's another partner, so we have another 2. And then we're multiplying those. And this guy's going to stay inside, because you can't participate in a 3-legged race if it's just you. So now we do 2 times 6, and we're going to get 24 square root of 2. Letter E, again, I'm going to come down here, leave myself some room right here for the final answer. I'm going to have my division house. I'm going to go ahead and I'm going to bring the 3 down to wait at the starting line. And I'm going to take my 125, the radicand. I'm going to go ahead and start dividing. Now, when we take a look, We cannot divide by 2, so we move up. Can we divide by 3? Well, the trick to see if a number can be divided by 3, if we add the digits together, 1 plus 2 plus 5, we're going to end up with 8. 8's not divisible by 3. Or just stick it in your calculator. So 3 is not divisible by 3, so we're going to move it to 5. It ends at a 5 or 0. We can divide by 5, and we're going to get 25. Can't be divided. Once you do this, start all the way back over again. If you're dividing by the smallest prime number, you're never going to go back to 2. Okay, that's how this works out. So then we can divide by 5 again, and we get 5. We have a prime number at top. Let's find our partners. Here we have a 5 to join at the starting line, and then we have another single 5 who has to stay inside. 5 times 3 will give me 15 square root of 5. All right, the next one here. Again, we've got the whole number that we're going to place in front to weight. On this one, I'm going to go ahead and show you the factoring with the perfect square like we did over, wrong page, right here. And I'm going to go ahead and show you why I don't like it. Okay, it's hard. Sometimes it's harder to find our partners. So I'm going to go ahead and go over here and say, okay, taking the square root of 216, and when we find what perfect square goes evenly into this, it's going to be 36, and that'll be 36 times 6. 6 is not prime, so you have to keep factoring out. This will be 2 times 3. Watch what happens here. This is 6 times 6, and each one of those will go to a 2, 3, and 2, 3. 2 times 3 gives 6, 2 times 3. Now, when we're finding our partners, this is what ends up happening with this, okay? We end up having to see, okay, I got a partnership here. See, I'm having to loop around, so you have to be careful with that. So here's a 2. I've got a pair of 3s. See that? That's why I don't like it, all right? But by all means, go for it, okay? And this 2 and 3 don't have a partner, so they're going to go on the inside. So now we're also seeing what happens if we have buddies on the inside. So 3 times 2 times 4 is going to give us 24. And then even though these guys are both inside, they don't have a perfect height match for the three-legged race, so they have to stay inside, and they could play video games or work on geometry homework together, giving us 6, and that'll be our answer. So I wanted you guys to see this, and now you understand this one kind of lines up, and even with the factoring here, we can see our partners, even factoring here with our prime numbers. Anytime we do that, the roots, what I call the tree roots, we can wind up with guys separated, and we could accidentally forget some. Okay, so that is going to be your simplifying radicals video.